Okay, the next law we are going to talk about is Graham's law. Graham's law is called Graham's law of diffusion. Graham's law of diffusion states that when gas rate state that the rate of diffusion of a gas is inversely proportional to the square root of its vapor density. Not density, it is vapor density. It says that the rate of diffusion of a gas, how a gas will flow, is inversely proportional to the square root of its vapor density. The square root of its vapor density. So if I introduce a constant, I will have my R to be equal to K over square root of D. So it's just a constant proportionality. And if I cross multiply, so K times 1 will give me K to be equal to R multiplied by root D will give me R root D. So in a situation where I have two cases, so I can say I can have R1 root D1 equal to what? R2 root D2. So I can rearrange this, and if I'm doing that, I will divide both sides by R2 root D1. Divide both sides by R2 root D1. So if I'm doing that, I will have R1, the square root of D1, divided by what? R2 root D1 equal to R2 root D2, divided by what? R2 root D1. So I will cancel, R2 will cancel R2 here, and then root D1 will cancel root D1 here. So if I continue, I will have R1 over R2 equal to square root of D2 divided by square root of D1. So you see that what we do here is the rate of diffusion of the gas is inversely proportional to the square root of its vapor density, and then I can introduce a constant. I have something like this. Then for two cases, I have R1 root D1 equal to R2 root D2. Then I can rearrange. I arrange it just to make sure that my rate are on one side and the density on the other side. So I divide both sides by R2 root D1. So if I divide by R2 root D1 will cancel with D1. I divide both sides by R2 root D1, R2 will cancel R2. So I can have R1 over R2 equal to square root of D2 over square root of D1. And don't forget that R here means rate. R means rate. And the formula for calculating rate of a gas is equal to volume of the gas divided by what? Divided by time. So it means R equal to V over T. R equal to V over T. So in the case where we have R1, so it means my R1 means V1 over T1 divided by, then my R2 means what? V2 over T2 equal to square root of what? Square root of D2 divided by square root of D1. So if I continue from there, I will have my V1 over T1. Why this divided is here? Divided by what? V2 over T2 is equal to square root of D2 divided by square root of D1. So if this division turns to multiplication, T2 will come up and then V2 goes down. And if I do that, I'm going to have V1 over T1 multiplied by T2 over V2 equal to square root of D2 divided by square root of D1. So if I multiply, V1 multiplied by T2 will give me what? V1 T2 divided by V2 multiplied by T1 give me V2 T1 equal to square. I can use one square root now for this. There's one square root here, there's one square root here. I can use one square root to cover everything. That is square root of D2 over D1. So we can also use this formula, square root of D2 over D1. But in some cases, the vapor density of this gas might be given. So if you are given the relative molecular mass, which is the RMM of the gas, so you can also use it to replace your vapor density, because 2 multiplied by vapor density is equal to relative molecular mass of the gas. So what am I trying to say is that in case you don't have vapor density of the gas given, if you have relative molecular mass, you can use it, because your relative molecular 2 multiplied by your vapor density is the same thing as your relative molecular mass. So they have same thing in common. So you can replace this one with relative molecular mass, so that I can have V1 T2 divided by V2 T1 equal to square root of relative molecular mass for gas 1 divided by for gas 2 divided by relative molecular mass for gas 1. So let's take a look at the first example. So let's take a look at the first example. If 50 centimeter cube of oxygen diffuses through a porous plug in 10 seconds, how long will it take 100 centimeter cube of methane to diffuse through the same plug under similar conditions? So you see that we have two cases here. The first thing we are talking about here is oxygen, and then the next gas we talk about here is what? Methane. Methane. So this is the first gas. This is the second gas. So the first gas is oxygen. You see that the first mentioned oxygen. Later talk about methane. That's the second gas they mentioned here. So the V1, the volume of the first gas here is what? 50 centimeter cube. And then they tell me that through a porous plug, it takes 10 seconds to diffuse through that porous plug. So the T1 is 10 seconds. So if I come here, the time taken for methane, which is CH4, to diffuse through that same porous plug, I don't know it. Because the question is saying how long this time will it take the second gas, which is methane, to diffuse through the same porous plug. So I don't know the time, but the volume of the methane, which is the V2, is what? 100 centimeter cube. And then the relative molecular mass for oxygen, RMM, for O2 is equal to, oxygen is what? 16. 16 multiplied by 2, give me what? 32 gram per mole. So if I come here, CH4, this is relative molecular mass of gas 1, relative molecular mass for gas 2, which is CH4, becomes, my carbon is what? My carbon is 12 plus hydrogen is 1. 1 times 4 will give me what? 4. So if I add it together, I will give me 16 gram per mole. 16 gram per mole. 16 gram per mole. So let's continue. Remember, according to Graham's law of diffusion, say that the rate of diffusion of a gas is inversely proportional to the square root of its vapor density. Square root of its vapor density. So if I introduce a constant, my R is equal to K over square root of D. Then I can cross multiply. If I cross multiply, and then K times 1 will give me what? K equal to R multiplied by root D. R root D. So for two cases as we have here, we have two similar conditions. So I can say R1 root D1 equal to R2 root D2. So I can divide both sides in order to rearrange. I can divide both sides by R2 root D1. So divide both sides. So I'm trying to rearrange it. So by what? R2 root D1. So if I do that, I have R1 root D1 here divided by what? R2 root D1 is equal to R2 root D2 here divided by what? R2 root D1. So we see that R2 we cancel R2, and then we see that root D1 we cancel what? Root D1. So at the end, you see R1 over R2 is equal to square root of D2 over square root of D1. Don't forget that we said the other time that rate is equal to volume over time. Rate is equal to volume over time. So for R1, that is V1 over T1, this divided by is here. And then for rate 2, that's V2 over T2 is equal to square root of the first gas is what? V2, and then the next one is what? Square root of V1. So if we continue, we have V1 over T1, this divided by, put it here, divided by V2 over T2 is equal to square root of D2 over square root of D1. So if you continue from there, we will have V1 over T1. This division, if it comes to multiplication, T2 will come up, while V2 will come down. Multiplied by T2 divided by what? V2 is equal to square root of D2 divided by square root of D1. So if you multiply this, you have V1 T2 divided by what? V2 T1 is equal to what? Square root of D2 divided by square root of D1. Don't forget that we said there is a relationship between the relative molecular mass of the gas and the vapor density of that gas. Because we said 2 multiplied by vapor density will give me relative molecular mass. So that means I can replace this density with relative molecular mass. So that my new formula can now becomes B1 T2, which is equal divided by B2 T1, which is equal to square root of relative molecular mass of gas 2 divided by square root of relative molecular mass of gas 1. So let's start inserting our parameters. My V1, the first volume of the gas, is what? 50 centimeter cube multiplied by T2. T2 is not given, that's what we are asked to find. I put it here, divided by my V2, the volume of the gas is 100, multiplied by the next one is my T1 is what? 10. Is equal to square root of relative molecular mass of gas 2. That is what we have here, 16, divided by relative molecular mass of gas 1. We have it here, 32. Square root of what? 32. So if we continue from there, we have 50 T2 divided by 100 times 10 give what? 1000 is equal to square root of 16. Or we say it's equal to square root of 16 over 32. So we can use one square root for them. One square root to cover this. That's 16 over what? Over 32. So if we continue from there, square root 16 here will give what? 1. 16 here will give what? 2. So I can have 0 will also cancel 0. And then 5 here, 1. 5 in 100 will give me what? 20. So I'll have T2 divided by 20 is equal to square root of 1 over 2. Please don't forget how we do this. What we really do is this. 16 here, 1. 16 32 give me what? 2. And then put the square root. And then I come here, 0 will cancel 0. 5 here, 1. 5 in the remaining 100 will give me what? 20. So if I have something like this, then I can divide each of them. So I'll have T2 over 20 is equal to square root of 1 divided by square root of 2. So I make sure that I split this square root. 1 is 5 its own square root, 2 is also 5 its own square root, just like as we have here. Then from here I can cross multiply. So if I cross multiply, I will have T2 multiplied by root 2. That will give me T2 root 2 equal to 20 multiplied by what square root of 1? That's 1. 20 multiplied by 1 will give me what? That was going to give me 20. So my T2 is equal to 20 divided by root 2. And what is root 2? Root 2 will give me 1.4142. So my T2 is equal to 20 divided by 1.4142. So by the time we divide it, 20 divided by 1.4142. So let's look at it and see what we have. My answer becomes 14.1. 14.1. So if I have 20 divided by 1.4142, I have 14.14 seconds. So my answer becomes 14.14 seconds. 14.14 seconds. Let's take a look at the second example.